So in this video, we want to make the communication between our Facetto Word server that we've started to make, that we can simply create a user and sign in and out at the minute, and the actual Facetto Word chat application. So in order to do that, to make the communication, we're going to make an API, which in essence is just a bunch of these web controller actions that the client can call through HTTP calls and get a response. So basically a bidirectional HTTP communication. That's all really an API is between the server and the client. So we're going to get started with that. So the first thing I'm going to do really though is to make the web client code in DNA framework so it's universal for any project, and just do a generalized web client communication, and then start to bake in things like the JSON formatting, HTML formatting, response codes, things like that. So the first starting point is we can press F5 on this Facetto Word server application, and the website should spin up and I think say hello world. I think the welcome page just ensures the database. If we've got no settings, makes them, and then returns the view, and the view is hello world. So yeah, this should just open up and say hello world basically. And there we go. Let me just turn on that so we don't blind everybody. There we go. So this is the server that we've already made so far. So that's up and running and working. So I'm just going to add another, for now, just to show what's going on, I'm going to add a call here. So we're just going to have a public action. We'll have the return type. We are going to return an actual object because this is an API call. So let's just pick a random object. Let's just use the settings data model and just call this test. And we'll just specify a root for now of test. So if we hit up our site called test, now we return, and instead of returning a view here, we're going to return an object because it's expecting a settings data model. So we'll just return a new one, id equals some id, name, Luke, value 10. So that's an object. This is a controller action that's simply returning an object. Now you might wonder how this is going to return a web page, if you will, because this is a requested HTML request. Well, you don't have to return a page. So iActionResult is generically anything. It's simply a result. This goes through a whole process in MVC to end up becoming a page if it is going to be a page. And the return view is what then creates a specific result called a view result that ends up being rendered as a plain text or a HTML document. But you can return any kind of object, and you don't have to specify an object. If you specify a generic class, then effectively what you return instead is an object result. And then you can return a new object result, and you can pass in an object. So that's what's really happening here. We're not passing in a view result, we're returning an object result, and then the object result goes through a bunch of, getting slightly ahead of the explanation here, but basically this goes through a bunch of converters, and I believe this is called content negotiation. So once we pass this off to MVC to return to the client, it goes through content negotiation, and this will pick a bunch of input formatters, or in this case output formatters, going back out to the client. And the built-in ones are JSON and plain text. So by default, MVC already adds a JSON content negotiator, and if it's an object, and that right now that's the only negotiator the only output format we have, this will get rendered as JSON by default. So we don't have to do this though, object result and return object result. The only time you'd want to do that is if you're potentially returning different classes or different models. So at any point you want to be a certain, a different model, but we're just going to return the settings data model. So we'll just go back to what we had, which is that, and we'll first run this, and let's see if we just hit up localhost /test. Then yes, I know I've missed the new. There we go. Then we should get this object returning a JSON string. So there's the hello world /test. And you can see now we hit this and you can see it's JSON. So if we press F12 in Firefox to get the network up and reload, and then you can see here's the call and we click it. There's what we made the call to test. It went as a get, and let me drag this up. The response from our server was that the content type is JSON. So that's why it's told us it's now picked and used to JSON. We requested with this accept header, by default this is just Firefox, that will accept text HTML, XHTML, or XML as defaults. But as I mentioned, because there is no XML output formatter, and it doesn't by default format objects as HTML, because you can't convert an object to a HTML. So those get ignored. So effectively all these accepts are not processable by the object result. So it falls back to the built-in one, which is JSON. And that's why we end up with this JSON result. And then you can see the response here, and there's the raw payloads. This is what ends up coming back to us directly, this string here, and that's JSON. So that's what's happening there. Now, with MVC and with the APIs, but you notice we don't specify here JSON. We simply say an object. So it gives the flexibility to the client, the caller, in the browser or in our client app to actually request different formats like here. So we could click edit and resend. And in the accept header, we could type in application /XML and then comma. And now we're going to ask for XML as well as the rest and click send. And you'll see here now, the type has still come back as JSON, but we did request XML. And that's because by default, MVC only has a JSON and a plain text output formatter. So what we'll do in order to just show you this mechanism, this optional way of converting this data to multiple formats, is we will actually add a XML formatter. So we go to the solution, we go to the startup, and we do it in this add MVC. So in the add MVC call, we want to add a specific option. So if we open the constructor, you can see we can do a setup action. So in that, we'll just call it options. And then in here, we've now got a bunch of options. So what you can do is options dot, and you've got input formatters and you've got output formatters. So input formatters will be when we accept, and we might as well, we accept a model coming in. So we'll say model. So that's an input formatter. We're now asking, when the client calls this route, we want them to pass as a model. And again, we're not specifying where it's coming from. So that's down to the input formatters to resolve. And then the output formatter is the return value of the server to the caller. So in the input formatters, we'll add a new XML serializer input formatter, I think it's called. Yep. And that's a built-in formatter that they provide. Copy and paste, change to output formatters, and obviously change that to output format. Right, so with that in now, if we run this again, this should now get picked up when the client requests, and the way the client requests a certain format, as I've shown here, is this accept header. So this is a header in HTTP. And this accept, this specific string of details, application /XML, text /HTML, this is called a MIME type. So if we were to go to Google and type mimetypes, and you can see this is you can get loads of different pages, go wherever really to find them. And you can see here these MIME types. And then you can search for JSON, say, and it's saying that's the MIME type. So this is where it's being pulled in from. XML will have loads because XML is kind of used in a lot of different places. It's probably just going to be the generic .xml. Okay, application, let's find it that way. There we go. So just the generic XML, which is a W3C standard as well. So this, if you want to find out different formats and do your own, then you can pass different MIME types in, but you don't really need to know much about them. You've got XML, you've got JSON, and we won't even use XML either. We'll allow it, but there's no need. We can do it all in JSON, which is less heavy on the amount of content being sent back. So now if we resend this, because we're requesting XML, the content negotiation for the output formatter, the thing returning data back to us, now has XML. That will be found, and it should pass through the XML output formatter, and then return, hopefully, XML. So not yet. So why do we not have accept XML? Let's edit, and let's just remove the others. Send. There we go. So the others were interfering. So because we've requested to accept XML specifically, it's the only header, we've now been returned XML. You're not seeing it up here because it simply doesn't display XML by default. So this is the old page, but you can see here the type's XML. And if we go to this request and go to the response, you can see it is XML, it's there. This is what was returned. It just doesn't show it up here. So don't get confused thinking it hasn't loaded XML, because it's saying right here it has. And you can see what I'm mentioning about the file size. So it's transferred 335 bytes compared to JSON that transferred 191, because obviously JSON's a lot smaller on the notation than XML is. So that's how we request a specific format back from our server, but by default it'll do JSON anyway. So in theory we should add into our calls when we do the client application JSON to be plain nice, and then if JSON wasn't the default format, it will always be, if it's available, it will return JSON for us. So we will add this when we make it to request that we want JSON, sending. So that gets us the calls back from the server with, JSON coming backwards. What we want to do now, though, is figure out, I'll show you how, well, we can't really show you in this one how to send the data that way. But we obviously want to send some information to the client, and that's part of the this input. So the input formatter will process this data. So when we make our web client, we will actually send this data through the body of the HTML request, and then we'll extract it from that and pass it through the JSON input formatter. So we have that done now. Let's jump to the DNA framework. So in here, let's start now and add a new folder called web. And we'll start by making some actual web request with a built-in web request. So we can't call our class web request because that's a .NET Core thing already, but we want to, it's very similar. We want to make helper methods to do it easier. So we'll call ours web requests. We'll then remove the surplus stuff. Public static, because we're not going to create an instance of this. Provides HTTP calls for sending and receiving information from a HTTP server. And then in here we'll start with a public static. It's going to be asynchronous. And we want to return a HTTP web response, which is just the built-in web response from the system.net.web request thing that we'll see in a minute. So that's what we want to return. And we're going to do a post. So what we have when we do the web calls is here, when you're just hitting enter and loading these pages, these are, as you can see, where are we? Here, the request method is get, which basically means it's just a request on the URL. This is the only piece of information we're sending. There is no body, there's no content being sent, it's just the URL. And a get can pass in some data by doing, which you'll have probably seen on some websites, and mainly older times, not necessarily now, is like, question mark ID equals something. And you can pass in data like this. And then you can do and name equals something else type of thing. And you can form data in here, but it's inherently insecure. So you never really use gets for sending data. It's a rare instance when you use gets. The only time you'll use a get to send data is things like in emails, when you get your email to say, oh, please verify your email address, and they'll email you a link. And when you click that link, it'll be some website, question mark, confirm ID equals, and then big long number sort of thing. And that's just a unique ID that's been passed in. So they can pull that in from simply you clicking a button. And it's just a single use, one-time key, if you will, to verify. So that's probably the most active use case for a get. What we want to do, though, when we're doing communication between the Facetto Word application and the website, is we don't use get, we use post. And a post simply means the content, like the information that we want to send to the server, we write to in the stream of the body of the actual request, which you can't see on just, Firefox when you open it and just press enter. There's nowhere to put the body content in. You're just typing up here. This is the response body. When you see the actual return value or you see the website itself, this is a response body. But we're sending a request body. We're sending a bunch of basically just raw data to the server. That's all you need to really think of it as. You send a web request, and then we write data like you write to a file. You write data to the web stream, and the server receives that. And that's called the body. So we're going to do a post because, like I say, that's the default way that I would send data to a server. So we'll call it post and then end it in async because it's asynchronous. One piece of info we need is the URL. Where do we want to send it to? So in our case, it'll be like localhost /test. Then we mentioned we want to send data to the server, or optionally send data. So we'll just allow an object to come in, and it's optional. So if you don't pass it, it's just null. And then we will also want to add a known type. So we can send the data in JSON, say, but let's at least add XML. We'll start adding an option, so we can serialize this as XML and send it as XML, or serialize it as JSON, just to give you guys a way to see how to extend if you wanted to send this object in some other way than JSON. So for that, we will add, let me think about this, what will we add? Probably just a constant, I think. Constant, say, because it's just going to be an enum. Known content types, let's call it. And then this will just be public enum known content types. And we will then pass in JSON and XML. So known types of content that can be serialized. In fact, that's known serializers. Known content serializers is probably a better name because it's specifically for serializing the information sent to a server. So known types of content that can be serialized and sent to a receiver, because to be honest, we could use it for anything else. The data should be serialized as JSON. And serialization, in case you don't know, and this is probably not the technical word for the word serialize, but in terms of what we're using for here, to serialize to JSON and to serialize to anything really in code, it always ends up being a string. So as you saw in here, the response, this is a serialized JSON string. So it's just a string and that is JSON. So to serialize, you take an object like the actual settings data model and you serialize it to the string. When you deserialize, you do the opposite. You take the string like this and you convert it back to a settings data model. So when we're sending the data, we're going to serialize to a JSON string, send it in the web request as a JSON string in the body, and then the server would deserialize that string and serialize it back into this data model. So that's how it's working. The same here. This is an object that not we, but MVC, using the output formatter, serializes this object into a JSON string, and that's what then gets written to here. That's how it's worked that way. So serialization and deserialization are going from an object to a string and a string to an object. But as I mentioned, that's probably not the technical term for, well, I know it's certainly in the technical term for just the word serialize, but in this context, that's the simplest way to explain what we're talking about. So when we serialize to XML, we'll do the same thing. We'll take the object and we'll serialize to an XML string, and this is XML. So you'd serialize to, as you've seen, something similar to that. So it should be serialized to XML. I'll probably change that to 2. So we'll pass in that as again an optional, and then we'll call that one probably return, well, not return, oh yeah, sorry, this is for what we expect to be returned. So we want a response from the server of a certain type, say. And then we'll also want the send type as well. So by default, we'll do JSON. We'll probably put the send type first. So we'd have that's the right place, yep. We'd have the send type and return type. So as in, what do we want to serialize this content in, JSON or XML? And what content do we want to return? You could have them the same, but we'll leave the flexibility. You might want to send it in JSON, return in XML, or whatever. So we'll leave that as an open option. But again, we'll only use JSON, but I'm adding it so you can see how it's done. Posts a web request to an URL and it returns the raw HTTP web response. The URL to post to, the content to post, the format to serialize the content into, the expected type of content to be returned from the server. So that's our call. So let's start with the basics. So we'd have, first we want to create the web request. You've got to start somewhere. So we'll have a request and it's a web request .create HTTP, and then it simply asks for an URL. So that's a good start. So we can have request, create a request ready to be sent. We want to make it a post request or a post request type. Method. Yes, so post request method. And that should be, so this is the other thing that's quite annoying. It wants a string for the method, and yet inbuilt to, in fact, before I complain too much, let's see if they have exposed it yet. Oh, there we go. And yeah, so that will do. Originally, I think this was like a sealed class that we couldn't access. So here's the bunch of ways to call, well, these ones here. So like I said, the default is get when you simply type an URL into a browser. A post is to send the data in the body. And then you've got things like put, delete. And put and delete are similar. They're simply a method type that the server can extract and say, oh, they've called a certain URL, but the type is delete, so they're expecting to delete. And that's, if you use delete, put, post, get, you've created then what's called the RESTful API, which you've probably seen. It's go to here, it's the RESTful. We like to type it like that. I don't use that. I don't bother with that. I don't like, for one, sending an URL to delete something, and the URL you're sending is just http://localhost/my/data/1. But because you've simply told the method type to be delete, this is now going to delete data. And yet there's no obvious sign in debugging or visual or anything that this is actually a delete request. So for that that reason alone, I never bother with RESTful APIs, as people call them. I simply use post and get, and then I make my URLs state the obvious. So my URL will be localhost/delete/my/data, whatever. It's in the URL, so it's obvious what's happening. I don't want to have the same URL with simply this changing to delete that you can't see anywhere, other than that line of code that's kind of doing some different action. So we won't be doing RESTful API, and at the same time, there's also no need. There's nothing, you don't have to follow everything that the industry shows you or tells you, or there's a big hype about certain names. Don't concern yourself going, oh, I must know that, or it's a big thing I need to know. It's not. There's a million different technologies and names and acronyms coming up all the time, but don't worry yourself with them. Just, as long as you can do what you need to do, you're good to go. So we are just going to basically we're making an API in the sense that you see here. We're sending posts and we're getting data back. So that's all we need to do. So that's all we're going to do. So as we mentioned in the Where are we? In here, when we requested XML, in our headers, we accept application XML, and this is a MIME type. So what we need to do is set the appropriate, couldn't spell appropriate then, set the appropriate return type. So we want to set the accept header, and that I believe is just a string. So we want to we want to set it now to the MIME type based on the known content serializer. So this is where we will need a helper class, because I believe in fact, we'll just make our own for how simple it is. The MIME types are just a big long list of known, basically a big long list of strings like you've seen on a website with the extensions and a return type of a string. And that is not anywhere yet exposed that I know of in the .NET Core framework. So we're going to have to clone that. And I believe I've kept a link to show you where it is in .NET Core framework. So let me just open up the browser. This is just browsing the source code of .NET Core. So you can see we're in the .NET Core FX, which is the .NET Core framework, in the system.net class. And they've got this thing called HTTP known header names. This is, I'm going off track here. This is another thing I was going to talk about, is the known headers. We'll come to this one. What I'm on about is the MIME types. So if you typed into Google, mimetypes.NET Core, say, there's a lot of people that will, this one's someone has made a class for that. But there's a lot of places where people are saying, how do I just get a MIME type? Like, from an extension to a MIME type, like we want an XML to an application /XML. And what you'll find when you read is, like, this is a classic one. It's just a very long list of MIMEs. So ASP.NET, which we're not referencing in our .NET Core library, has this class here that we could make use of by creating a new one and then passing an extension and then returning these. But the bottom line is, there's no real place in code right now in .NET Core where we can just say, well, we've got XML, we want to return application /XML. You could do it through extension and through referencing this class or cloning this class, but for now, for what we need, what we're going to do is just specifically, which I don't like doing, but specifically just make a class that will return the set ones we want to know. So we've got right now two known serializers. We've got JSON and XML. So we're just going to make a class that returns application /JSON or application /XML. And even though it's just a MIME type, and they are constants in a sense, I'm not going to bother importing a huge list of constants into this for now. So I'm just going to shortcut this instead, make an extension method. So known content serializers, extensions, and we will remove the junk as usual. This will be public static extension methods for known content serializers. And in here we'll have public static, we want a string, we'll say to MIME string. And obviously this known serializer, and we'll do a case or a switch rather on the serializer. Default, if we don't know it, we will return what is widely classed as the generic MIME type if something's unknown in W3C standards, which is an octet stream. And that's simply it is technically a type, but that's become used as the generic unknown. If we have JSON, we'll return the known application /JSON. And if we have XML, we'll return application XML. And we'll comment all this. Takes a known serializer type and returns the MIME type associated with it. The serializer switch on the serializer, JSON XML unknown. So there we go. We'll also add, let's see if this works. I don't know whether this works on control dot and add to dictionary. I think that adds to the actual dictionary of Visual Studio. Yeah, not to here. So we don't want to use that. I don't think we can undo that now though. So serialize has gone into my dictionary somewhere else. But for now I know it wouldn't typically be in. So let me add it to there. And XML and JSON will add, just so my spell checker doesn't highlight those as invalid words. So if we close and reopen that, they should now stay valid or not. Did that not save? Yep. So what's that complaining about? Oh, because it's unknown. It's actually got unknown with that's see, that should be ignoring it because we've got JSON in there. Oh, I've got an ignored file, so I put it in the wrong place. Clear. Ignored words. XML, JSON, Serializer. There we go. Close, reopen. There we go. So all this is doing is, like I say, taking an enum, so we can hard type a specific type of expected serializer, and then get it to give us a MIME type that a web request knows. So that's all we're doing there. So now in this accept, we can easily take the return type and do doc to MIME string now. And all that's done is basically said if it's JSON, return application JSON, otherwise application XML for XML. But done it in a nice, clean way. So that's that out of the way. Then we have look to set the content type, which is the send type. So we could set the content type to manufacturer, we just set it as just the same. So content type equals send type dot to MIME string. I'm just thinking if we don't pass data in, you know, if content's null, then setting the, well, I guess it doesn't really matter in that case. So if you're sending no content, it doesn't really matter what you tell it you're sending. So it will just default to JSON or whatever's passed in. It won't make a difference. That's fine. So we tell the server what type of content we're sending. We must set the content length, which tells the server, because we're going to write to a stream, and we could fail, we could miss bytes, anything could happen. We need to tell the server how many bytes we are expecting to send before we send any. So if content is null, then set content length to 0. So the request dot content length is 0. Otherwise, now we have the option here to serialize based on the send type. So we could do a helper function here, but because we've just got 2 for now, I'm just going to switch, just do an if else statement. In fact, if content is null, we've only got 2 types, so it has to be a known type for now, so that's fine. Yeah, so I'll just do an if statement for now for simplicity. So if send type equals JSON, and then to be honest, we should do else if send type equals XML. And even though there's no other option, we should also do an else in case currently unknown. And we should probably at that point throw an error. But we have no we have no error handler at the minute. So I want to throw a specific error handler. So let me just put it to do in here, because once we have DNA framework exception types, I don't want to go off in this video and start making exception handling stuff. But what I want to do here, and this is the way we want to make functions going forward, is the way to report errors in things. We will basically throw an exception, but we'll throw a specific exception with a specific exception error code if it's an expected, like here. It's currently unknown, so we'll return a specific exception, a DNA exception, with a human readable string that says, we don't currently know the send type serializer, but then we'll send a hard-coded error code specific to this one exception. It can be thrown nowhere else in our whole application. It'll just be an integer, say the number 7. And if that's thrown in unit testing and in any other testing you want to do, you can call this function, pass it in an unknown type, and expect to be thrown an error with an error code of 7, for instance. And that's how you'd unit test. But for now, I don't want to go down that rabbit hole, so I'll just put a to-do here for now, which is fine. So otherwise now, serialize to JSON or serialize to XML. So to serialize to JSON, JSON String is the serialized result. JSON convert, control dot, use newtonsoft.json, and serialize the object, and then just pass in the content, and that's it. So serialize content to JSON String, and that was as easy as it was. Why is it still complaining about JSON even though we have ignored words JSON? Maybe we just need to close and reopen web requests. There we go. So we've got the string. Now we just want to set the content. In fact, we could split this up into, no, we want to have var content string equals, in fact we can, yeah, that's fine, content string, create content to write. Now in here, all we have to do is set the content string that way. If it's XML though, we'll have a bit more work on our hands. Not much, but a little bit more. We have a new XML serializer. I don't use XML much, so I'm trying to think. Type of content. Can we do that? Is there what you'd like to have? Well, we know we've got content. Get type. Yeah, that's it. So we create a serializer. Now we can't just do dot serialize with data, you see, in this, which is annoying. You have to create a write. You can't just pass in a string, so it's kind of annoying. So what we do instead is we make a variable for the serializer. So create XML serializer, and we'll just pass in. We'll make a memory stream, just an in-memory stream. Memory string equals new memory stream, and we want the encoding of the string by default to be UTF-8, and so we'll get the bytes. Hang on, am I thinking this? No. What am I doing? Oh yeah, so you got to pass bytes into the memory stream. I am thinking right. So you want to get the bytes from the object. Oh wait, no. No, I'm thinking of the other way around here. This is for deserializing back to a string. We're trying to serialize to a string, aren't we? So we have string writer equals new. I think that's the thing. Yeah, string writer. I think we can just use it here. XML serializer. Dot serialize. Going slow here because I'm having to think this one through. So it's the string writer we want to write to, and there we go. Now the object is the object. There we go. So if we pass in the writer, so that's it. Create a string writer to receive the serialized string. Serialize the object to a string, extract the string from the writer. So now the content string will equal the string writer dot, I wish they'd stop automatically doing the wrong thing. String writer dot to string, I think. So I think that's how we do the XML serialization. Notice JSON's nice and easy. That's why we use it. XML is a little bit more messy. So between those, and like I say, I haven't tested this yet. I presume this will work. But the basic idea is we need to set the content of the request, the content passed in, what we want to send to the client, the server. So if we have no content, we don't do anything. If we do have content, then we expect to send it as JSON, we serialize to JSON and set this. Otherwise, we set it based on XML. Otherwise, we throw an error there, which we haven't done yet. So after we've done that, after we've basically created the string, we then just want to write it to the body, and this is where the post comes in. So now, write content to BodyStream, to HTTP BodyStream to make it clear. So to do that, we do another using, because we need to dispose of the streams. So request stream equals, and then you have to await the request, the HTTP, the web request thing we made above here, the actual web request. So we await the get request stream async. So we ask for the stream, now we've set up all the headers, we've set up the accept, the content type, the length, the method. We can now request the stream. You have to do that first so that the server knows how to respond, because it can affect the stream. So we get the request stream. On top of that, then we need to create another one, stream writer this time, and stream writer, and the stream will be the request stream. And then with both of those, we just do await stream writer, because now this is a way that we can write to the body stream, because it's connected to the request stream. I really shouldn't have named this stream writer because it keeps going to the wrong case. Stream writer.write async, and I think hopefully it accepts a string, something to write by default. Yep, there. So we can just pass in the content string. So write the content of the body stream. So that would be that comment. Get body stream. One thing I don't like about this is it clearly indents the comments in the wrong fashion. It indents comments to there, but then indents the using to there. So if we were to say close the tag, you can see, oh no, it's fixed it now. So create a stream writer from the body stream, and then I like to do the progressive ... until we get to the call. So that writes to the body stream. So the final thing, make sure I'm inside the right thing here now. So we've written the content. So this can be region setup, because this is setting up headers. This can be write content. And now we can simply return the request dot get response. So now doing get response will send the whole request to the server, and we'll get a response. It will return though by default a web response. We want to return a HTTP web response because we know it's HTTP because we've created a HTTP there. So that will be as HTTP web response, and we just return the response. Return the raw server response. So this will be a generic HTTP. We need to add to the unignored words. So this is now a generic post call. So we can make use of this and call that, and then get a response from the server. And we'll take it one step further after that. So let's now let's close this project and open up, or rather just open up project solution, and it'll close this one. So we go to the Facetto Word source and Facetto Word, save everything we've done. And what I'll do again, because we are in, we're using the NuGet package at the minute. Right click, properties, browse. We'll uninstall our DNA framework. Uninstall. Then we will right click the solution, add existing project. We'll add back in the current framework we're working on right now. This is what we had before we had the NuGet package. And then in the references, we will just add a reference back. So this should all build now still. Yep, so that builds. So we're now in a position where we're in the Faceta Word application. It starts up, we do something here. So we can now call web requests.postAsync, and we can post, say, http localhost/test, or I think it's localhost:5000/test. Everything else is optional, so content, types, blah, blah, blah. So we should just be able to at first for result equals, or in fact, we're not in an async task here, so let's just do task.run async, cut that in, and var a equals result, just somewhere to breakpoint on. So if we run this application now, but first we run the server, the server is running, we can breakpoint here to see, and we can breakpoint here to check and press F5. So the server's running, so we should have that endpoint active. And we should hit this, and we'll step through it, we'll step into the code for the first run so you can see it going line by line. So F11 into this. So the setup, we want to request a HTTP call to here, localhost 5000/test. Of course, we're on async, so I'll just breakpoint an F5 to that. There we go. Then the method we want to be post, so that gets set up as post. The accept wants to be JSON, so it should turn into application/JSON. The content type is JSON, so same thing. Now we want to write the content, so there's no content, so it sets content length to null. And now it requests from the server. So as soon as we hit this line, we should get the response. Well, the server should hit its breakpoint, or not. So we've got a result because, in fact, we have no result. What went on there? ID status waiting for activation. Okay, what went on there? Let's have a look at the, close that now, close that. Okay, so what's waiting for activation? That's new to me. Oh, hang on, we haven't awaited. We need to await the request to get the result. That'd help. So we stepped all the way through, but then we just returned from post async without awaiting it. So this time we just press it, and we should get all the way to the end. And if we hit the other one, and we just can't see, yeah. So we've hit this breakpoint now. We've got no data. We return, and we should have a result now from the server. And there you can see we've now got the UTF-8 character set. The content length is -1. Content type is given as JSON. All the same information we saw in Firefox. It's a post method this time though. The server responded okay. And the content though, that you can't see here, is in the stream. It's returned it as a stream. So you can't just see that because it's a method. But we have the result. So we know we've got a result. Status code's okay, which is status code 200. So we've now got a response from the server. And that response is this response here. So it's this exact response. And we will have got this response back. But this is in the response stream that we have to extract. So you can see we've had all these same headers. We've got this header, we've got the kestrel, we've got the chunked info. We've got all that information come back. We've got the status code okay. So we're getting exactly the same response through this call. So now we're talking from the Faceta Word application to the server. And we've simply hit that URL. We haven't passed in any data yet. So we will now, well, we might as well then pass in some data. So the content, let's just pass in. It's expecting a settings, we just did this as a demo, so a settings data model. But we don't have that in the Faceta Word application and it isn't shared. So I'm just going to copy this class in for now and chuck it down here, if I can put it there. We don't need key, don't need comments. We're just mimicking the same POCO class. So now this is the kind of info it's expecting. So if we were to pass in the new settings data model, ID equals from client, name equals Versetto word, just passing any info, value equals ha. And there we go. So we pass this in. We'll step through that once more to show you the JSON serializer working. So we go into the request, we do the normal stuff, but this time we have content. So now the content type is JSON. So it's going to do the content string serialize content. So it's going to serialize this object that we just made. I have to ignore this one stepping through its own code as well. And now we've just jumped over there, so we're back to where we are. So now the content string, as you can see, is the JSON string. So this is now going to get written in the stream to the server. So as we write to the stream there, and then we send it to the server should now, if we jump over to the server, should now have got that. But what I think you'll notice is the model is still null. It's not pulled in. So even though we've sent it to the server, the server hasn't received it. And the reason the server hasn't received it is another thing that you need to be aware of is the input formatters and the content negotiation. So the output formatter happens on the accept header, and then it knows what type to serialize to. The input, though, because when you don't specify a specific route or a specific request method, like say HTTP post, and even if you do, this input can come from multiple places. So it could come from cookies. It could come from the URL itself, as we mentioned with like the localhost /test model equals blah blah blah. So it can come from the query string. It can come from the body, which is where we want it to come from. It can come from form data. So there's multiple places where this data can come from. And simply by saying there's the data and we'll pass it in as the body unfortunately is not the default place where it looks for that data. So in order to tell it that we're expecting this data to come in from the body, we've already told it what the content type is going to be because we've set the, where are we? We've actually set up the content type here. So the server knows that we're sending JSON because we've told it, but it doesn't yet know where it's coming in from. So to force this data to be found from the body, which is where it comes in, because that's where we write it to. We get the request stream, which is the BodyStream, if you will. I call it the BodyStream anyway, but basically the stream of the request. We write it to that. Then we want to tell this with an attribute coming from body, like that. So if you put the square brackets from body in front of this, we run that server again, nothing else has changed. And then we run the client app again. So that's now running. Let's go to Versetto Word and we run this one again. We should now send that request off to the server. Don't want to breakpoint there. And now in here, this is the server. Hopefully, there we go. We've now got the info from our client. So from client, Versetto Word ha. So we've received data, and this went through the input formatter. So we said it's coming from the body. The content type tells it it's JSON. And then the content negotiation says, well, it's JSON and it's an input format. So it looks for the input formatters, which has already got JSON in, and it looks for the JSON serializer input formatter, passes it into that. The JSON serializer converts it back to this object using JSON convert.deserialize, and we end up with the data. So that's kind of what's happening. So now we've got the data from the client, we send data back, and as you see, the results come back, but the data is again in a stream that we now need to pull it out of. So that's the last step to making this kind of initial communication. So on the web request side, we now have this post async, which is good. And we just want to make another function now. So it will first be exactly the same as this function. So we will copy, I'm just thinking what the description will be. be basically the same. So we'll copy the whole signature of the method, paste it, so we now have an identical method. The difference is we want to parse the returned information back into an object. So all we'll do for that is we'll make a generic method, and we'll call it tResponse. So this is generic. I've done a video on generics. So posts a web request to a null and returns a response with the expected data type of the expected data type. Everything else stays the same. So the first step to that is make the standard post call first. So this will be server response. We'll await the post async call above, so the non-generic one. Just pass everything in. And that's all of it. So we get the normal one. All this method does now is call this method. So now we get a HTTP web response. So from that, we want to create a result, what we're expecting to return. Because this is now a structured post, we're going to say we expect this data called settings data model. And we need to know if that succeeded or failed or, what's gone on. We are going to need some return type for that. So we'll create something, we'll call it, I don't know, web request result or something. We won't go in constants, we'll just go here. So make a class web request results. And we're doing this because we want to be able to return things like whether it was successful or not, if it failed, why. It's now a more detailed response. It's not a raw HTTP server response. It's going to be our specific response that we figure out what's going on and if it's returned the right type and things. So this will be a web response from a call to get specific data from a HTTP server. First one we want, obviously, as we mentioned, is if it's successful. If the call was successful. If it wasn't successful, we want an error message. If something failed, what was the message? And failed, this is the error message. In fact, successful can then simply be if error message isn't equal to null, because you might want to set it to a blank error message in case it fails. So we have the error message, then we'll have the HTTP status code we'll want. That's a useful piece of information. So that's like the 200 if it was okay or not. So we'll keep that from the original response. Status code. We'll have status description because that comes in with the raw response, and I'm guessing it's a human readable status. Okay, succeed, unauthorized. So it's useful information that we'll pass in. We'll want again, more useful info is content type. The type of content returned by the server, and that'll be a MIME type. So we could potentially convert that to our type, but we'll keep it raw for now. Then we'll want the headers. So we'll have web, I think it's web header, web header collection, there we go. So that's all the headers passed in. And the headers are as we've seen multiple times now, that the headers from the response are here, response headers. So that's a collection of those. All the response headers. Same with, we might want cookies. So let's get the cookies. And I'm doing all these because we're not necessarily using all these right now. But as it grows, bear in mind, this is a completely generic web request class I'm making. This is useful information if you want to use the higher up version to basically deserialize the response into something, but you still want access to you know, a lot of the key data that comes in with the raw response. So any cookies sent in the response. We'll have the raw server response, so that's the body. We might want that. We can, for now, we'll pass it in. But if, say that's a huge amount of data, that'll all go into memory and RAM on this machine. So we may not want to always receive that. But for now, again, keep it simple. It's good for now, and then we can refine later. So the raw server response body. And finally, we'll have the object itself that we're deserializing, the server response, the actual server response as an object. So that's the whole class that we'll use. But because that's not, you know, a type, we need that class so we can simply pass a result back, if you will. But we want, again, same class, and we'll use generics again to have a type. And that will inherit the web request result. So in fact, it's the same thing. A web response from a call to get a specific data type to get call to get a generic object data to get generic object data to get specific data. So there we go. The type of data to deserialize the raw body into. Deserialize is not a word again, apparently. Web request result. So all we want to do for this one is do a public new server response. I think that's what we called it. Yeah, so all we're doing is taking a normal class where you can have just an object in case you don't know the type. But if you do know the type and you pass the type in, it will then make a nice helper property that can return it as that set type. So you'll see that in use in a second. Cast the underlying object to the specified type. Doesn't technically cast in as well, it does cast. So there we go. We have now a result that we expect to return. So that was a bit long-winded just to get the starting post of what we want to return, but now we can return the web request result now. And now we want the T response. So we expect a specific type to be returned that matches this type. So now we'll have a response type based on the response we pass in. Again, this will make more sense when we call the method, but you'll see that will now help us to construct a response. So we can create a result. So first we'll just make a general result, which is just this class. But instead of doing new web request result, because what you'll see is there's a web request result of T response, and then we typically fill in. You'd start by saying say it's successful, say it's failed. Well, not that. Say you've got like your content type. So content type would then be server response.content type. Headers would be server response.headers. And all this, like every single time you want to make a result. So we'll make use of what we did in the last video, which is we'll do this, but we'll make it from an extension method. So we'll do server response, and we want to say create web request result, say. And it'll need to know the T response. So it needs to know which type to create it out of. And that's it. So we want like an extension method now to help with this. So we'll make another class in web called HTTP web response extensions. Remove that, public static class, extension methods for C HTTP web response. And that will work in a minute once we have the extension method. Yes, and then what did we call it? Paste that in a second. Called it that. t response, and that will be a web request result t response for returning. And then you just return a new thing, and the extension will pass in HTTP web response, control dot, include the namespace, server response. So that's a basic extension method. Returns a web request result pre-populated with the HTTP web response information. The type of response to create, a server response. Return a new web request result. Content type, headers. Now I can fill in the rest, so just server response dot cookies. We have raw server response. We'll get that in a minute. Server response is the thing. Is status code server response dot status code. Status description. I'm pretty sure it has one. Server response dot status description. Yeah. Spacebar got stuck. Oh. Yeah, the spacebar keeps getting stuck. Status description. So now we're left with error message, which is up to the caller to set. The server response will naturally be, well, we'll fill that in based on the type later. So both of them will get filled in. The raw server response, though, we can get. So we can do, in fact, we won't return it there then, because result equals the response. We should only expect to get like an actual stream that we can open if the server has returned a 200, I think, for now. And presume unless it returns a status of OK, it's trying to tell us something which potentially, well, which I would say always means you're not going to have a response body. So I'd say read in the response body. Yeah, my spacebar is properly messing up at the minute. I'll have to change that. So if we got a successful response, so if, oh, this is really annoying, this is definitely got a dodgy spacebar at the minute. So if not successful, if status code, oh, 1 second, let me try and fix this keyboard. There we go, just the spacebar kept getting stuck. So if result.status code is OK, so the 200, then we will read in the response. And like I say, we might change this in future, but for now, that's what I think we need. So we'll do it using var response stream equals server response dot get response stream. Then we need to do the same again. Stream reader, new stream reader, response stream. So open the response stream, get a stream reader, and then read in the response body. So now the result.raw response will be stream reader dot read to end. And I think that is it. So that will create us a, oh yeah, we have to return the result. That will create us a result nice and easy in a little extension method. So we can now do create web response result. There we go. So this should now convert our initial raw HTTP web response into this nicer web request response. And it should also have read out the body now. So if we then let's just return the result for now and call it, and we'll breakpoint on it and see what happens. So the app now, instead of calling post async and raw, all we need to do is say we're expecting it to return a settings data model like that. And now in this call, because we've passed in now settings data model there, we get it here, we pass settings data model into here. So therefore we create this object that's got now a server response of that type in the return result. And it won't have anything yet because we don't set it, but it's there as a type. But what we do is then read the raw server response. So when we run this, presuming the server's still running, yeah, this should at least now read the body out for us and also give us, like I say, this nice class that we've made to set up information on it. So we hit here, this is the server. We don't need to see the server being hit now, we've seen it being hit. So we've got the server response as we've seen before, and the result now has the content type in it, the cookies, which are none, error message none, we've got all the headers, so we've got all the 4 pieces of info, and now we've got the raw server response, which has been read from the body. So you can see the info here finally has come from the server of what we want. So the last step now is to convert that up to our original class, this now settings data model, so that we can simply make a request to the server like this, pass in an actual class, and get returned whatever class we want in one single call. And all we have to do is tell it the endpoint that we're asking for. So this is the start of making the, as you can now see, the communication between the client and the server. So we could now say, if we're sending a message, we could just say new message model, and the ID is our ID, the name is whatever, the message is what we want. And we can send that info up to the server. It can store it in the database, send it off, all the push notifications to the people the message went to, and return back a model that says whether it succeeded or not and whatever info, all within a single line. So this is what we're building it up to. So we have that response, we've got the result. So now, like I say, we want to convert this to an actual, we want to JSON deserialize it, or deserialize it based on the expected, serializer. So what we want to do first here is, now we've got the result, it might not have succeeded. So if the response, in fact, the response might be null. Would it ever be null? I don't think it'll ever be null. No, pretty common. Again, if it happened to be null, we'll fix it at that point. So if the response status code is not 200, so if result.status code isn't equal to OK, in this instance, like I say, we can change it as we go, but I'm going to presume call failed, and we'll give it a reason. And we'll have a to-do to localize this string in a minute. Localize string. So we'll set the result dot error message to server returned unsuccessful state status code. So basically something other than 200. So we'll pass that info into the message as well. Server response dot status code and server response dot description. So it's at least an informative piece of information that can be given out. Done. So that'll just return the result now, the failed result. So this is the check if it succeeded or not, based on the status code. If we succeeded, then we want to now convert or deserialize raw response. And I guess that's if we've got a response. So if we don't have a response, then I think the only thing left to do is return the result again. So if we have content to deserialize, or if we have no content to deserialize. So if result.raw response dot, and then this is where I'll make a helper function as well. So how we have to do string dot is null or empty. and then you pass in the string. As I mentioned in the last video with extension methods, I don't like doing this way around. I want to do result.response.is null or empty. Makes much more sense. So we'll just quickly make another helper method. So strings, add class, string extensions, remove that, extension methods for strings, public static boolean is null or empty, this string content return string.is null or empty content. Turns true if the string is null or an empty string. The string, and then we might as well just copy and paste that and do the other one. Is null or white space. Or is null or an empty string or just white space. That'll do for now. So now we should be able to do that, which we do. So if we have no content to serialize, if it's null or empty, then just return result. Done. Otherwise, why is deserialize still showing as deserialize? That shouldn't be showing as a typo. Yeah, okay. So now we just want to deserialize the result. So this is where we'll have the switch again for now, or simply we'll have to try and catch this because this could fail, and then this is where we'll throw our expected. Well, in fact, we don't want to throw here. We just catch an exception, but the deserialize could fail. So instead of throwing, in this case, it's an expected potential failure. So if deserialize failed, then set error message, because they're expecting a result that can be failed. So we might fail for a different reason. So in this case, the result would be, or the error message to the result, failed to deserialize server response to the expected type. And then they can gain the rest of the information from the actual object. And then we'll return the result again. Not that it matters because it'll fall through, but to make sure we go. Return result there. So in here now, we simply want to check if the, what did we call it? The content, the send type. So it's the response, so it's the return type, what we want to deserialize. So if return type equals JSON, we do JSON, else if return type equals XML, we do that. Else, in this case, we'll do similar to the other one, where it's an unknown deserializer, basically. So we would copy and paste that, and we would change the message to unknown type, unknown return type, cannot deserialize server response to expected type. So that's kind of, again, if we don't know the type to return, and then we know to come into here. So JSON, or ISON apparently, JSON XML unknown. So we have JSON. It's again nice and easy. So the one thing we do want to do is check, or if the server response type was not JSON. So we also want to check, as we've seen on the websites, we can request for, say, XML, but it returned JSON when it wasn't set up. So just simply requesting to the server that you want JSON doesn't necessarily mean you've got JSON back. So we should check if the server's told us the content type. So we'd have server response dot content type dot to lower. If that contains, because again, the return type contains application JSON, but it's got character set at the end. So we can simply say, if the content type contains our MIME, we'll presume it's the right type. So if it contains the known serializers.json, in fact, we've got the return type dot to MIME string, and we can make that universal for all of them to do a check. So we don't have to do this check every time. So if we cut that, actually, if we want to deserialize, first we check if the server type was not the expected type. So this would be if it's not contained within the content type. So we're saying if the server returns content type here, like application JSON, but we've said to be application XML. So if it doesn't contain it within the content type, we're going to say, hang on, there's an error. The server didn't respond, didn't reply with the expected type. So fail due to unexpected return type. So it could be server did not return data in expected type. And then we can also pass in the type that it did return. So we could say expected received, and then that would be server response dot content type, and this would be return type dot to MIME string. So then we'd give information back to the caller. That's obvious. So that's a protection to make sure first the type should be of the type we're expecting it to be before we try to deserialize. And then deserializing is just as easy as the other one. It's literally one line. So it would be result dot server response equals JSON convert dot deserialize object as the expected type, and the string value is obviously now the result dot raw server response. Deserialize JSON string, and that's it. Again, the XML is a little bit more work. If I can remember where we've got the XML serializer, I can just copy and paste most of it. So we do that, copy and paste it's in the same request. So we will have in here, it's similar, like I said, it's not the same. Create the serializer. This time, though, it will be type of tResponse. And then create the string writer will now be memory stream. Create a memory stream for the raw string data. So there's a memory stream, and in fact, there's almost no point copying and pasting that. The result.server response equals now the XML serializer dot deserialize, and we'll pass in the, oh hang on, we haven't put the data in the memory stream, but that's where we get it. So deserialize string to serial XML string. So the memory stream, we need to actually pass in the info. So this would be the encoding. We need to tell it what format our string is, which by default should be UTF-8. And the get bytes from the result.raw server response string. So basically convert the UTF-8 string into bytes that can go into the memory stream that can now be read into deserialize, which will go back to a string. But unfortunately, that's the way we do it. Deserialize Does this accept generics? No. Deserialize an object, so we just need to cast it to a expected T response. So that should deserialize XML as well. I know we're not using that, but that's fine for now. So if we run this now, we should have basically the finished result, if you will. So we hit this now, and we step over that, we know the response. So we have the response, we get the result. We now see the result with the JSON in because that's what we requested. The status code is okay, so it's fine. It's not empty, so it comes into here. It's now going to look at the content type, which is application/JSON with character set, but our return type is JSON, so it should be included. So it passes that logic. Then it goes to a JSON and it deserializes the raw response, which is that string, into the server response object, which is now back up to a full object, and then returns the result. So what we're now left with from that call is we actually have a server response that's got a settings data model that's got the info from the server. So that is now, we've made that call, and we can now do result dot server response dot, and now we've got the hard-coded, info from the server. We're back to C# classes. So that's kind of the whole web structure there. It'll get improved and added, but that's the starting point now where we can log in from this application. So when we click the login button now, we can construct a login data model, pass the info in, the username and the hashed password that the user sent, and send it to the server and get a response and see if the server returns us with an access key. So this is the starting point to now finally get these two things communicating. So let's just do a quick change on this to just show you the XML. Let's make sure the XML at least works. So we can have the sent type to be XML, and I think that won't matter, so we can send it as XML, and we should still get the result back just fine because our server has an XML input serializer, and the content header will get set correctly, so everything should just simply work, and the result should still come back. Yes, you can see there. It all went through as XML by going to into here, post the data, serialize, and then it did this. So if we were to restart this, you'd see that it comes into this call here, and we serialize the content, and then it writes this to the server. So it writes this string now instead of the JSON string, and we set the content type here to XML. So the server's handled that for us fine, which is what we expect. So now let's check if it can return the XML as well. So we'll change the return type to XML, and again we'll end up with the same object, but on either side it will now return XML data. So that would be the result. It's fine. Response, now we expect this time to have XML. The response says we have XML, which is correct. So this time it goes to the XML, gets a serializer, memory stream, and deserializes it. And obviously the raw response from the server was this. So it sent back XML again, and that still worked and deserialized into the same object. So the bottom result is there. We've technically just communicated via XML, but nothing in our code has to change other than we told it to do that. We can also really quickly test the server, our fail logic, if you will. So let's just comment out these. So we don't handle XML and spin this up. And then in the Word application, let's not make it fail on send. Let's at least send the expected type of JSON. Let's just simply ask for XML back. And this should fail to send XML back because, well, it won't. It'll send JSON back by default, as we saw. But our logic should catch the fact that we've got a result that doesn't match. So now the content type is return JSON, you can see, but we're expecting XML. So this is now going to error out. We're going to return, and our result is going to say successful. Successful true is wrong. Why is it successful? Let me just go to I think I must have done my logic back to front. Successful is if it equals null, not if it doesn't equal null. You plonker. There we go. So if the error message is null, it's successful. Good job, we checked that. So we have the post, we get the result, and it's now successful false, and the message is server did not return the expected type, expected XML, received JSON. So I'd say that's a pretty success. Oh, poop, I've moved that out of the way. Oh, this never goes back where you expect it to now. Eeny, meeny, miny. Oh, now I've got two. I'll fix that after. So hopefully that was useful for seeing now effectively how we communicate between a client application and a server, and that you can see every single part of it. This web folder is in essence the whole lot, and it all just boils down to this class here. So again, there's no mystery about it. There's no complexity. But what we've done is constructed it and then built it into a nice set of helper methods, so it keeps it easy and clean on the client. That now the client can make one single web request like this, one-liner, to get information back from the server, and you're literally sending a class and you're returning a class, or the other way around, you're sending a class, returning a class. So it makes it really easy to work with. So again, as usual, any comments and questions, let me know in the video, in the comments below. And also, I'll just mention I've now got a Patreon. Let me know how you pronounce that. I'd say probably Patreon. So I've got a Patreon page if you want to support what I'm doing. I'll leave the link in the description. Every little helps. So if you feel this was useful, you can support me on the Patreon as well. So any comments or questions, let me know, and hopefully this was useful.